गुड इवनिंग टू ऑल ऑफ यू गाइस और आप सभी का एक बार फिर से स्वागत है बच्चों बायजूस एग्जाम प्रेप में. So today we will discuss the formula which is required for the structure analysis part. But guys, what I will say over here, from this particular subject, for this particular subject, the concepts are more relevant as compared to the formula. If you know the concepts, then you are able to apply the formula easily, because only certain conditions are there which you have to remember as a formula, but rest of the thing just you have to use it. Okay, तो बच्चों इसका मतलब ये हुआ कि भाई आपको यहाँ पर सबसे ज्यादा कंसेप्ट पे ध्यान देना है as compared to formula, right? But today we will discuss the formula, whatever formula which is required as per the examination for the structure part, that we will discuss in this particular session. So please share this session to other student so that everyone can join over here. सभी को शेयर कर दीजिए बच्चों फटाफट से. Okay, so those who are watching this video first time, let me tell you about myself. My name is Krishna Yadav and I'm teaching from last 10 years, right? So guys, we have the GATE exam analysis on 4th and on 12th of Feb at 1 p.m. and 6 p.m. Kindly join it, right? So, okay. Guys, one more thing, you can register for the GATE 2023 rank and the plan ahead on the 15th of Feb. This will be a live, right? That is basically GATE rank predictor tool, right? For this, you have to register, right? Okay, there is one non-tech marathon, guys, which will be starting from 13th of Feb. You can join it on YouTube, right? For the ESE prelims examination. Then we have a scholarship test on 7th of Feb at 7:30 p.m. which you can join, and you can register it also, guys, for our upcoming GATE examination, and you are able to avail the up to 90% of scholarship on the GATE preparation program. Okay, so let's start the session, guys. Let's start the session quickly. So please write down hi, hello. Please write down, guys, hi, hello, so that I can understand everyone is live over here. Then we'll start our session. Hi Anwar, how are you? कैसे हो जी? You can watch my RCC formula revision video also, guys, if you want to revise your RCC subject. Okay, so let's start with the first topic, that is basically indeterminacy. That is basically indeterminacy. Now you know that, guys, there are two type of indeterminacy we have. One is static and second is basically kinematic, right? So for these type of indeterminacy, right, for static indeterminacy and for kinematic indeterminacy, what should be our formula? Let's understand one by one. Okay, so first we'll discuss the static indeterminacy part. What should be our ds value? So you know that, guys, we can write ds is equal to how much? It is dsc plus dsi. What is dsc? dsc is nothing as external static indeterminacy. dsi is internal static indeterminacy. Now let us suppose, guys, if you have a 2D structure, if you have a 2D structure, and in 2D structure also we will have, let us suppose, rigid jointed structure. Rigid jointed structure. For rigid jointed structure, what is the formula to find out DSE? It should be RE minus 3. What is RE? I'm good, Anwar. RE is nothing as total external support reaction, right? Next one, let us suppose, guys, if you have a truss or pin jointed structure. Pin jointed structure. For pin jointed structure, again, the same formula is applicable to find out the DSE value, and it is equal to how much? RE minus 3 again. Now, if you want to find out the internal static indeterminacy for rigid jointed structure, right? Internal static indeterminacy, that means DSI. So there are two formula which you have to use in the exam. One is based upon member and the second one is based upon number of closed loop. So you know that, guys, how to calculate the DSI value? It will be 3m minus 3j minus 3, right, and minus RR. So this is one of the formula to calculate the internal static indeterminacy, in which m is total number of member, j is total number of joint, RR means total number of reaction release. Okay, now the another formula which we have is DSI is equal to 3c minus RR. C is total number of closed loop, RR is total number of reaction release. Okay. Now guys, if you want to find out internal static indeterminacy for pin jointed structure, internal static indeterminacy for pin jointed structure. So DSI can be written as M minus 2J minus 3, and we have only single formula to calculate it, right? M minus 2J minus 3. M is total number of member, J is total number of joint. So these are the formula for 2D structure. Now let us suppose guys, if we want to calculate the static indeterminacy part for 3D structure, how we can calculate it? Hello Dinesh. For 3D structure, how to calculate the DSE value? DSE is equal to RE minus 6. What is 6? 6 is nothing as our total number of static equilibrium equation, which are summation fx0, summation fy0, summation fz0, mx0, my0 and mz0. Okay. And this formula is applicable for rigid jointed as well as pin jointed. Rigid jointed and for pin jointed also. Okay. The next one is basically DSI. So DSI in case of 3D rigid jointed structure, the formula will be 6M minus 6J minus 6 minus RR, right? Again, M is number of member, J is total number of joint, RR is number of reaction release. So guys, let us suppose if you have an internal hinge, right, like this. So for this particular internal hinge, how many reaction release are there? It will be 3 into M dash minus 1. What is M dash? M dash is nothing as it is the total number of member meeting at that particular joint. Hi Kanvi. Okay. Next one is basically DSI again guys, to calculate the internal static intimacy for pin jointed structure, and the formula is M minus 3J minus 6. M minus 3J minus 6. But this formula is applicable for pin jointed structure. Pin jointed structure. This formula is applicable for pin jointed structure, and this one is applicable for rigid jointed structure. Rigid jointed structure. Kanvi, you have to check on the application, right? So for this particular information, you can contact to the support team, or either you can check it in our app, right? So these are the formula to calculate the internal static intimacy and the external static intimacy for 2D structure and 3D structure. I think it is clear to all of you, right? Now let's understand what are the formula we have to find out the DK. That is basically kinematic indeterminacy. How we can calculate kinematic indeterminacy. So let's understand for 2D structure first. For 2D structure, first one is rigid jointed structure. Rigid jointed structure. For rigid jointed structure, the formula will be dk is equal to 3j minus re minus nr plus rr. What is j? Total number of joint. What is re? Total number of external support reaction. What is nr? Number of inextensible member or total number of axially rigid member, right? And what is rr? Total number of reaction release. Now similarly, I want to find out the value of dk for pin jointed structure. So for pin jointed structure, dk will be 2j minus re, right? Okay. Then we have 3D structure. For 3D structure, what will be our formula to calculate the dk for rigid jointed structure? Guys, in this way we will revise all the formula which is required as per your subject, right? Dipanshu Gupta, I am defining each and everything. NR is nothing as that is basically the total number of axially rigid member or inextensible member, right? Very simple. NR is total number of inextensible member or axially rigid member. You can write it down, right? Okay. Then rigid jointed structure. For rigid jointed structure, what is the value of dk? dk is equal to 6j minus re minus nr plus rr. Right? Again, in this case, J is total number of joint, R is total number of reaction, NR is total number of axially rigid member or inextensible member. RR is total number of reaction release. If you have pin jointed structure in 3D case, pin jointed structure in case of 3D, so dk is equal to 3j minus re. Now tell me guys, all of you are able to understand the intimacy part or not? Very easy chapter. Hardly take 5 to 10 minutes to revise all the formula. Are you able to understand? Please write down in the chat box. If you know the formula already guys, then only you are able to revise over here. If you are learning the formula first time in this particular session, then it will be not helpful for you guys, because there are some fundamental which you have to understand before learning these formula directly. Okay. Okay, now let's move to the next one, which is basically analysis of determinate truss. Now you know that guys, in case of analysis of truss, there are two conditions. One is basically to find out the forces in various member by using method of section and method of joint. And the second one is basically deflection of a truss joint. How we can find it out, right? So guys, first how to analyze it by using method of section and method of joint. Method of joint. If you have a method of joint, so how many joint equilibrium equation you have to apply? Basically two, to find out the internal reaction in each and every member. And how many static equilibrium equation are required to find out the external support reaction? 3. Summation fx0, summation fy0 and summation mz0. So for external reaction, 3 static equilibrium should be used: summation fx0, summation fy0 and summation mz is equal to 0. To find out the internal reaction, you need to use joint equilibrium equation, which is summation fx0 and summation fy0. Now let us suppose guys, if I want to solve the problem by using method of section. Method of section. For method of section, let us suppose if I want to find out the external support reaction. Again, I need to use summation fx0, summation fy0 and summation mz is equal to 0. Getting a point? But if you want to find out the internal reaction in each and every member, then again guys, you have to use the same number of static equilibrium equation, right? Which is summation fx0, summation fy0 and summation mz0. That means to find out the forces in internal member, we need to use the static equilibrium equation. Getting a point? Now let us suppose guys, if I want to find out the displacement of a truss joint. Let us suppose this is a truss. And I need to find out the displacement of this particular joint. Let us consider this joint is C, this is A, this is B. Okay. I need to find out the displacement of joint C in the horizontal direction, how much it is, right? So how you can calculate delta C? That is the question. So very simple formula guys. Delta C can be written as summation PKL upon A. And the summation will be I/1 to I/n. What is P? P is nothing as, that is basically our P system of force due to given load, right? So what is P? P is nothing as, it is the forces in all the members due to the given loading system, right? This is P system of force. Force in each member due to given loading. Next one is what? K system of force. Now after removing the applied load, what you need to do guys, you need to apply the unit load at the same point where you want to find out the deflection and find out the force developed by that particular unit load. That is basically K system of force. K system of force, right? And this is nothing as force in each member, due to unit load, right? What is L? Length of member. A, cross section area of member. E, Young's modulus of elasticity. Now guys, this is the condition when the loading is given to us. But let us suppose guys, if loading is not given and directly they have mentioned the value of displacement. So our formula will change. Let us suppose delta C will be written as I is equal to 1 to I is equal to N, and in place of PL upon A you can write del I into Ki. What is del I? It is nothing as change in length of each member. Change in length of each member, right? Which is directly given in the question if loading is not mentioned. And again, case system of force will remain same as we have discussed in the previous concept. Next one is, let us suppose if change in temperature is given for each and every member. So delta C can be written as summation I is equal to 1 to I is equal to N. In place of delta, you can write L alpha delta T I into Ki. Now what is L? Length of member. Alpha, coefficient of thermal expansion. Delta T, change in temperature. What is Ki? Again, it is the force in each member due to the unit load, right? So I think all of you are able to understand how to find out the displacement in case of truss. Getting a point or not? These are the formula which you have to remember, guys. Are you able to understand or not? Please write down in the chat box. Please write down quickly. Okay. Next one is basically influence line diagram. So in influence line diagram topic, guys, we don't have much formula, but to be true, you need to understand the concept part, right? The concept part is more important in case of influence line diagram, right? But I will tell you certain things which you have to remember for the ILD also. Okay, let me tell you that. So let us suppose if this is our simply supported beam, right? If this is a simply supported beam, and let us consider this support is A and this support is B, and this is our section C at a distance of A at a distance of B from here, right? Now guys, if I want to draw the ILD for RA, it should be like this. That means this value is 1. This is ILD for VA or RA. Similarly, let us suppose if I want to draw the ILD for VB. So our ILD will be like this. This is again 1 and this is nothing as ILD for VB. Okay. Next one is if I want to draw the ILD for shear force at C. So it should be like this, right? This is negative, this is positive, this is A by L and this one is B by L. Please remember these ordinate. ILD for shear force at C. Now if I want to draw the ILD for bending moment at C, ILD for bending moment at C, it should be like this, right? And this particular ordinate is how much? It is AB by L, right? And this is theta 1 and this is theta 2. Getting a point? Please remember these things, very, very important for your examination purpose. Clear? Now guys, the rest of the thing like effect of moving load. In effect of moving load, one concept is more important that I will discuss, but the rest of the concept, the rest of the things are not formula. Just you have to understand the concept. Like if you have a UDL, then which area you have to load according to the maximum stress value, so that we will get the maximum stress value or maximum value of that particular stress function. So those things are basically concept, not a formula, right? So let's understand guys, one of the case which is more important as per the ILD, and in play and that concept may be asked in the GATE examination. Okay, let me explain over here. Okay, now let us suppose guys, if you have a simply supported beam and let us consider the length is L, and I want to find out absolute maximum bending moment. I need to find out absolute maximum bending moment, and let us consider there are two loads. One is this, second one is this, and this load is P1 and this load is P2, and the distance between P1 and P2 is Z. Okay, and let us consider this is basically the center of the structure. Now what you need to do guys, listen carefully. Let us consider P1 is greater than P2. Now what you need to do guys, you need to find out the CG of the load system first. right? How you can find it out? Let us consider this is our origin and we need to find out the z bar distance. So z bar from here, right? So guys, P1 into Z plus P2 into 0 divided by P1 plus P2. Getting a point? So this is our Z bar where we can say that guys the center of gravity will lie, right? Now the distance between CG and P1 is Z1 and the distance between P2 and CG is Z2. Now what you need to do guys, you need to put the heavier load which is basically P1 and it is nearest to CG also. If you calculate it, you will get Z1 is less than Z2. That means P1 is heavy as well as nearest to CG. Now you need to place this particular distance Z1 on the structure so that it will be divided equally by the section C, right? Which is nothing as basically our center. It is equally divided by the center of the span. So in this way, you have to put your load system to find out the absolute maximum bending moment. So this is the major concept which can be asked in the GATE examination. Now you know that guys, rest of the thing which is available in the ILD, all those are basically concept, right? Not the formula, right? So this one is basically P1 and this one is P2. And what is the resistance? This one is Z1 by 2 and this one is also Z1 by 2. And below this particular load, you will get absolute maximum bending moment. Clear? Crystal clear? So these are the things which we want to discuss from the ILD part, right? Now let's move to the next one, which is basically the strain energy method. Now in strain energy method, guys, you need to remember the formula to calculate the strain energy. So how you can calculate the strain energy due to the flexure? That is basically integration m square ds upon 2ei. This is basically due to flexure. Then total strain energy due to axial force will be F square ds upon 2ae. And this is basically due to axial load. Now what is M? M is basically bending moment at a particular section. What is ds? It is nothing as it is the length of an element. Again, F is what? The axial force on our section and ds is the length of element again, right? In this way you can calculate the strain energy of the member by if it is present in the form of flexure, if it is present in the form of axial load, right? But let me tell you guys where it is more important. In case of rigid jointed structure, the strain energy can be the function of axial force, shear force and bending moment. But at the time of analysis, what you have to do guys, you need to consider the total strain energy is the function of bending moment only. Why? Because the strain energy which is stored in the structure by using shear force and axial force is very less as compared to the bending moment. Like the total strain energy, whatever total strain energy is stored in the structure, out of that 90 to 95% is stored by the bending moment and the rest of the energy is stored by the axial force and shear force, and that's why we are trying to neglect it in our analysis, right? So the total strain energy is the function of bending moment in case of rigid jointed structure. But let us suppose guys, if you have a pin jointed structure, for pin jointed structure, the total strain energy will be the function of axial force only. Getting a point? Only axial force. Clear? Okay. Now let's move to the next chapter, which is basically moment distribution method. How to write down the compatibility equation in arches, I will explain it. Okay, let's understand the moment distribution method, MDM method. So in MDM method guys, first formula is which is very important, that is basically stiffness. stiffness. So guys, let us suppose if far end is fixed. Let us suppose if far end is fixed, then what should be the stiffness? Stiffness is equal to 4 EI by L, right? This is A and this is B. So our stiffness is from A to B. That is basically 4 EI by L. Let us suppose if far end is hinge. Far end is hinge or either it is roller. Far end is roller. Then in that case, again KAB is equal to how much? It should be 3 EI by L. Right? This is our stiffness. Now let us suppose if far end is free, then stiffness will be 0. Then stiffness will be 0. Getting a point? Please remember these formula. Okay. Next one is basically carry over moment. Now if you apply certain moment over here, let us consider M, then what should be the value of carry over moment at end B? So MB is equal to how much? MB is equal to M by 2, right? M by 2. If you apply a certain moment over here, that is basically M. So the carryover moment at the far end will be equal to 0. So in this case, MB is 0. In this case also, MB is 0. This is our near end where we have applied the moment, but at the far end, it is not possible to bear it. That's why MB is 0. Getting a point? Okay. So these are nothing as basically carry over moment. Carry over moment. Carry over moment. Clear? Okay. Now, what is the formula to calculate the carry over factor? Carry over factor. What is the formula to calculate carry over factor? That is basically COF. So COF is nothing as carry over moment upon applied moment. Carry over moment upon applied moment. Now guys, tell me if you have far end as fixed. If far end is fixed. If far end is fixed, then carry over factor is how much? How much is the carry over moment? It is M by 2. So M by 2 divided by M. M by 2 divided by M. So carry over factor will be half. If far end is hinge or roller or free, then in that case carry over factor will be 0, right? Why it is 0? Because carry over moment is 0. That is the reason. Getting a point? Okay. Now I think up to this, all of you are able to understand the carry over factor, carry over moment and stiffness part. Now the next thing which we need to discuss here, just a second guys, let me add some more slide. Okay, just a second, right? Let me add some more slide so that it will be more easy to write. Okay. Now up to this, I think all of you are able to understand what is carry over moment, carry over factor when we have far end as a fixed, far end as a hinge or roller or free. Now guys, let us suppose if I want to calculate the fixed end moment, right? Fixed end moments. Please remember these formulas also. Fixed end moments due to the loading and due to the settlement of support. Fixed end moment. Fixed end moment. So let's take one by one the different cases. Let us suppose guys, this is a fixed beam in which a load is applied exactly at the center and this distance is L by 2 and this distance is also L by 2. So what is our moment at this particular end and what is our moment at this particular end? Let us consider this is A, this is B. So this one is MAB bar and this one is MBA bar, right? Which is nothing as moment at support A for member AB and this one is moment at support B for member AB. Clear? So the value of MAB bar will be minus WL by 8, right? PL by 8 or WL by 8. Similarly, BA bar will be plus WL by 8. Please remember the anti-clockwise direction should be negative and the clockwise direction should be positive. Clear? Next one is, let us suppose if a point load is there which is present at a distance of A from the left support and at a distance of B from the right support. This is A and this is B. Now what is the value of MAB bar? Minus, let us consider this is P. So PAB square divided by L square, and MBA bar will be plus PA square B by L square. Clear? Now let us suppose, guys, if we have a UDL on the entire span. If we have a UDL on the entire span, W. This is A and this is B. And let us consider length is L. So MAB bar will be minus WL square by 12 and MBA bar will be plus WL square by 12. Clear? Let's move to the next formula. Guys, I am telling you those formula of fixed end moment which is very, very important as per your GATE examination, which you have to remember, right? Okay. Next one. Let us suppose a concentrated moment is present exactly at the center, that is M, and this distance is L by 2 and this distance is L by 2. So the moment at support A and the moment at support B will be same and their direction is also same. So this is A and this is B. So MAB is equal to, MAB bar is M by 4, right? Then MBA bar is again M by 4. Please remember this. Okay. Getting a point or not? Okay. Next one is if you have a UVL. If you have a UVL like this, uniformly varying load. This is W, this is A, this is B. So we'll have a moment like this. So at support A, MAB bar, the moment value will be minus WL square by 30 and MBA bar will be plus WL square by 20. The moment at this particular location will be higher as compared to this one, right? So these are the formula which you have to remember for the GATE exam purpose as a fixed end moment due to the given loading system. Okay. But let us suppose, guys, if you have a settlement of support condition. For settlement of support condition, kindly remember these formula. Let us suppose this is support A and this is support B. If support B will settle down by some delta, so our direction of settlement is this. So it is clockwise. Then the moment at end A and B will be anti-clockwise. So this is A, this is B. So MAB bar and MBA bar, both the value will be same and it is equal to minus 6 EI delta by L square, right? Now let us suppose, guys, if one end is fixed and other is hinge and it is trying to settle down by delta, so this will be our moment at the fixed end, but there is no moment at hinge support. So definitely we will have certain value and that value will be MAB bar will be minus 3 EI delta by L square and MBA bar will be equal to 0. Clear? Please remember these formula. Now let us suppose, guys, if the settlement of support is occurring in opposite direction, like this support is trying to move in upward direction and this support is trying to move in downward direction, like this. So let us consider this one is delta 1 and this one is delta 2. So what is the direction of settlement? It is basically anti-clockwise. So the moment which will be generated at support A and at support B will be clockwise. And the net displacement will be delta 1 plus delta 2. Getting a point? So the value of MAB bar and the value of MBA bar will be same and both are positive in nature because it is clockwise. And how much it is? 6 EI delta 1 plus delta 2 divided by L square. This will be your formula. Getting a point or not? Now let us suppose, guys, if you have settlement of support in same direction, okay, the support is trying to settle down in the same direction, then what should be our formula? Let us suppose this is trying to settle down by delta 2 and this one is trying to settle down by delta 1. This is delta 1 and this one is delta 2. The net displacement is delta 2 minus delta 1. So direction of settlement is clockwise, then the movement will be anti-clockwise in nature, right? So MAB bar will be minus 6EI. Now the net displacement will be delta 2 minus delta 1. Delta 2 minus delta 1 divided by L square, and MABA bar will also be same. It is minus 6EI delta 2 minus delta 1 divided by L square. In this way you can calculate the fixed end moment for the settlement of support. Up to this, any doubt guys? If you have, please write down in the chat box. Then we'll discuss the distribution factor, then we'll move to the next chapter. Okay, crystal clear? Very nice. Now the next one is basically our distribution factor. Distribution factor. So distribution factor is what? It is nothing as stiffness of a member divided by summation of stiffness, right? Stiffness of a member divided by summation of stiffness. That is our distribution factor. What is relative stiffness? What is the formula for relative stiffness? Relative stiffness can be calculated as stiffness of a member divided by 4E, right? Now let us suppose guys, if far end is fixed, then the relative stiffness for that member will be equal to how much? 4EI by L divided by 4E. So our formula will become I by L, right? Now guys, if you have hinge support on the far end or roller support on the far end, then the relative stiffness will be 3EI by L divided by 4E. So again you have to cancel E to E and you will get your answer 3I by 4L, right? Crystal clear or not guys? All of you are able to understand? Okay, the next thing which is very important guys, all these are nothing as basically concept. These are not formula to be true. If it is formula, then मुझे लगता है कि फिर आपने थोड़ा कम पढ़ा है भाई. मुझे ऐसा लगता है बच्चों की formula नहीं है. These are basically concept part which you have already learned in the your preparation duration. Getting a point? Okay. Because if you learn these things as a formula, then फिर structure का मतलब नहीं रहेगा, right? यहाँ पे structure analysis का मतलब नहीं रह जाएगा. Okay, these are not formula, these are just concepts which we have to apply. Okay, the next thing is basically rotation. Now let us suppose guys, if I want to find out the rotation of any particular joint, right? Let us suppose some movement is applied at a particular joint, then what should be the rotation at this particular joint by using MDM method? Let us suppose the stiffness of this member is K1 and the stiffness of this member is K2. So you can write here the rotation of this particular joint will be M by summation K. If you want to find out the rotation of a particular joint where the moment is applied, you need to use this formula, theta is equal to M by summation K. Simple, right? Done. Next chapter is basically slope deflection method. In slope deflection method guys, kindly remember the slope deflection equation. Let us suppose if you have a member like this is ruler, this end is A, this end is B, and this length is L. So I want to write down the slope deflection equation for A to B, then B to A. Then what will be our formula? For A to B, MAB bar plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. This is our formula. Similarly, BA will be MBA bar plus 2EI by L into 2 theta B plus theta A minus 3 delta by L. सार्थक हिंदी में समझाएं, इंग्लिश समझ में नहीं आती है, कोई बात नहीं, दोनों में समझा देते हैं ताकि सभी को समझ में आ जाए. सो बेसिकली बच्चा ये हम स्लोप डिफ्लेक्शन इक्वेशन की बात कर रहे हैं. स्लोप डिफ्लेक्शन इक्वेशन होती है, अब ये तो इंग्लिश में बोलो हिंदी में बोलो, तो हिंदी में कैसे बोलेंगे इक्वेशन को? ये तो समझ में आएगा यार, है ना सार्थक? इक्वेशन तो समझ में आएगी ना, इसको तो हिंदी में बोलने की जरूरत नहीं है. एम ए बी बार प्लस 2EI बाय एल प्लस 2 थीटा ए प्लस थीटा बी, राइट, माइनस 3 डेल्टा बाय एल. ठीक है, ये तो समझ में आ गया। हाँ बढ़िया, ठीक है, बस यही समझना है। ये क्या है बेसिकली, दीज आर नथिंग एज स्लोप डिफ्लेक्शन इक्वेशन। देखो आपको हिंदी और इंग्लिश दोनों आ गई। दीज आर नथिंग एज बेसिकली स्लोप डिफ्लेक्शन इक्वेशन, ये स्लोप डिफ्लेक्शन इक्वेशन है बच्चे। नाउ व्हाट इज एम ए बी बार, व्हाट इज एम बी ए बार? एम ए बी बार और एम बी ए बार क्या है? फिक्स एंड मोमेंट्स हैं। थीटा ए थीटा बी, these are nothing as rotation of joint A and rotation of joint B. Delta is nothing as settlement of support A or B. If it is given, then you have to consider. If it is not given, don't consider it. अगर दिया होगा तो कंसिडर करेंगे, नहीं दिया होगा नहीं कंसिडर करेंगे, ठीक है। नेक्स्ट इज जॉइंट इक्विलिब्रियम इक्वेशन। जॉइंट इक्विलिब्रियम इक्वेशन, अच्छा इसके साइन कन्वेंशन बता देता हूं। लेट मी एक्सप्लेन द साइन कन्वेंशन फॉर दिस। साइन कन्वेंशन में क्या है, इफ यू हैव अ फिक्स एंड मोमेंट, इफ इट इज क्लॉकवाइज देन पॉजिटिव, इफ इट इज एंटी क्लॉकवाइज देन नेगेटिव। अगर क्लॉकवाइज होगा पॉजिटिव, एंटी क्लॉकवाइज होगा नेगेटिव। थीटा के बता देता है, थीटा अगर रोटेशन क्लॉकवाइज होगा देन इट इज पॉजिटिव, एंटी क्लॉकवाइज इट इज नेगेटिव। डेल्टा के लिए अगर डायरेक्शन ऑफ सेटलमेंट क्लॉकवाइज है दैट मींस इट इज पॉजिटिव, अगर डायरेक्शन ऑफ सेटलमेंट एंटी क्लॉकवाइज है देन इट इज नेगेटिव, ठीक है, ये ध्यान रखना जी, ठीक है। डायरेक्शन ऑफ सेटलमेंट का मतलब क्या हुआ, जैसे मान लो यार बी सेटल कर गया है ना, बी सेटल कर गया तो आपका बीम कुछ ऐसा हो जाएगा। यार थोड़ा सा है ना लिखने में आपको राइटिंग अच्छी नहीं लगेगी, उसका रीजन सिंपल बताता हूँ बच्चों। मैं यूज करता हूँ ओपन बोर्ड, जो कि अभी सॉफ्टवेयर में कुछ इशू हो रहा है जो चल नहीं रहा है। मैं अभी यूज कर रहा हूँ पीपीटी, जिस पे लिखना थोड़ा मेरे लिए डिफिकल्ट होता है, इसलिए मेरी राइटिंग आपको परफेक्ट नहीं लगेगी, थोड़ा सा ऊपर नीचे काफी दिखेगा। ये मैं आपको सही बता रहा हूँ भाई, है ना। अगर यही चीज़ मैं ओपन बोर्ड पे लिखता तो मैं प्रॉपरली उसे बहुत ज़्यादा अच्छे से लिख पाता, बट इस पर राइटिंग अच्छी नहीं आ पाती है बच्चों पावर पॉइंट पे, है ना। तो थोड़ा सा आपको इसके लिए कॉपरेट करना पड़ेगा मेरे साथ। बाकी हाँ, आपको कंसेप्ट पार्ट, फॉर्मूला, एनी अदर थिंग इफ़ यू नीड आई विल एक्सप्लेन इट, देयर इज़ नो प्रॉब्लम, ठीक है। चलिए नाउ गाइस, लाइक दिस, इन दिस केस द डायरेक्शन ऑफ सेटलमेंट इज व्हाट, यहाँ पे डेल्टा कैसा बन रहा है, क्लॉकवाइज, सो वी नीड टू कंसिडर पॉजिटिव, सिंपल लाइक दिस, ओके। नेक्स्ट वन इज जॉइंट इक्विलिब्रियम इक्वेशन विच इज वेरी इजी। मान लेते हैं बच्चों नेक्स्ट वन इज जॉइंट इक्विलिब्रियम इक्वेशन। लेट अस सपोज दिस इज अवर स्ट्रक्चर and this is one of the end, this is another end. Let us consider this is A, this is B and this is C. I need to write down the joint equilibrium equation at joint B. तो यार what you have to do, you have to apply the moment in the clockwise direction at the support, or not at the support, exactly in the member. For member you have to apply clockwise moment, for member clockwise, for member clockwise. और let me break the structure first. मैं पहले एक काम करता हूँ, स्ट्रक्चर को ब्रेक कर देता हूँ ताकि आपको ये देखने को मिल जाए, ठीक है। चलिए देखिए, स्ट्रक्चर को ब्रेक करते हैं। जॉइंट बी पर मैंने ब्रेक कर दिया। So what you have to do, you have to apply the moment in a clockwise direction for the member. So this one is clockwise, which is MAB. This one is clockwise, which is MBA. This one is clockwise, which is MBC. This one is clockwise, which is MCB. Now you need to apply the moment. You need to apply the moment at the joint in the anti-clockwise direction, like this. This is MBA and this is MBC. So what is our joint equilibrium equation? Summation of moment at this particular joint will be equal to 0, right? तो यहां पर आपको कुछ नहीं लिखना, सबमिशन मोमेंट एट जॉइंट बी 0 कर देना है। सो व्हाट एग्जैक्टली यू विल गेट, MBA minus MBC will be equal to 0 and this is your joint equilibrium equation. Clear? So this is for slope deflection method. Next one is basically our arches. So for arches guys, what is the value of horizontal thrust? Very important. Just remember the horizontal thrust values, it is very important, right? So this will be WL by 4H, PL by 4H, K8H. Tell me guys, what will be the value of horizontal thrust when you have a point load on a 3D hinge parabolic arch? Tell me guys, PL by 4H or PL by 8H. प्लीज राइट डाउन, क्योंकि मैं ही काफी देर से बोल रहा हूं, आप भी बोलिए भाई. Please write down quickly. Tell me guys, tell me quickly. नहीं पता? Okay, no problem. What you can do guys, let me do you one simple analysis in front of you so that you can understand how to find out the reaction part. You know that this is W. Let us suppose this is our span. This is L by 2. This is L by 2. What is this value exactly? W by 2. This one is also W by 2. Now what you need to do guys, you need to take the moment at C is equal to 0. अब moment C is equal to 0 ले लेंगे तो हमारे पास क्या होगा यार, VA इंटू एल बाई टू हो जाएगा माइनस HA इंटू एच हो जाएगा. तो यहाँ से क्या मिलेगा भाई हमें, यहाँ से हमें सिंपली HA का वैल्यू फाइंड हो जाएगा. सो HA इज इक्वल टू हाउ मच, HA इज इक्वल टू VA L बाई 2H. व्हाट इज द वैल्यू ऑफ VA? W बाई 2. तो ये हो जाएगा WL बाई 4H. ये रहा फॉर्मूला भाई, राइट. Now tell me, what is this? This is formula or some concept? This is basically concept, right? Now, if you have a UDL on 3D hinge parabolic arch on the entire span, the horizontal thrust is equal to WL square by 8H. Please remember this formula also. Okay. Next one. If you have a 3D semicircular arch and a point load is present exactly at the crown, then the value of VA is W by 2, VB is W by 2, and HA is also W by 2 and HB is also W by 2. Sub W by 2 bhai, right? Next one, if a UDL is there on the entire span in case of 3D hinge semicircular arch, then what should be the value of HA? What should be the value of HB? So first of all, what is the value of VA? W into L by 2, that means W into 2R divided by 2, that means this is WR and this one is also WR. Now let's calculate the value of HA and HB while considering moment at C is equal to 0. हम ये कंसिडर कर लेते हैं moment C पे 0 है, तो HA और HB कितना होगा निकाल लेते हैं बच्चों. VA into R minus HA into R minus W into R multiply by R by 2 and it should be equal to 0. तो VA का वैल्यू कितना है यार, WR, तो ये हो जाएगा WR स्क्वायर माइनस HA into R माइनस WR स्क्वायर बाई 2 एंड इट शुड बी इक्वल टू 0. तो HA का वैल्यू निकल के कितना आया, क्या मैं बोल सकता हूँ WR बाई 2 एंड दिस इज योर हॉरिजॉन्टल थ्रस्ट. HA एंड HB इज इक्वल टू हाउ मच, WR बाई 2. क्लियर, डन. नेक्स्ट वन. नाउ लेट अस सपोज गाइस, अगर मान लीजिए आपके पास, जस्ट अ सेकेंड. Now let us suppose guys, if you have two hinge arch, so for two hinge arch, please remember this point. If you have a semicircular arch, अगर आपके पास semicircular arch है तो I उसका कांस्टेंट होता है. अगर parabolic arch है तो I का फॉर्मूला हो जाएगा I into I naught sec theta. What is I naught? This is the minimum moment of inertia at the crown, right? What is theta? Theta is nothing as angle which you have to calculate on this particular parabolic arch by drawing a tangent over it, है ना. तो थीटा कैसे निकालता है, बड़ा सिंपल है बच्चों. व्हाट इज द इक्वेशन ऑफ पैराबोला? इट इज 4h इंटू एक्स डिवाइड बाई एल स्क्वायर ब्रैकेट एल माइनस एक्स. अब ये क्या होता है सर? दिस इज बेसिकली इक्वेशन ऑफ पैराबोला. इक्वेशन ऑफ पैराबोला, राइट, इन विच h is what? Rise. h is rise, central rise. h is central rise. L is basically span length. What is x? X is nothing as, it is the distance, or it is the, yes, it is the distance of the section at a from the left support, right? And this is nothing as y. Y is nothing as rise from the at this particular distance. What should be the our rise value? Like this. ठीक है? Hi Rohit. Now guys, how you can calculate the theta? You need to take the derivative of this equation. So dy by dx is equal to tan theta, and tan theta can be written as 4h by L square bracket L minus 2x. This will be our formula to calculate the theta, right, at any distance x. Now the next one is basically compatibility equation. So do you remember, guys, if you want to calculate the horizontal thrust in case of in case of two hinge arch, then the compatibility equation is what? H is equal to integration my ds divided by ei divided by y square ds upon ei, right? This is our formula, or this is our compatibility equation to calculate the horizontal thrust in case of two hinge arch. अब बच्चों जैसे अगर देखा जाए ना, गेट एग्जाम में आपसे वो इतनी इक्वेशन नहीं लगवाएगा, अगर लगवाता भी है तो आपको डायरेक्ट फॉर्मूले पता होना चाहिए, खासकर टू हिंज आर्चेस के हॉरिजॉन्टल थ्रस्ट के, तो वो मैं आपको डायरेक्ट बताता हूं, वो आपको याद रखना है, ठीक है। बाकी उन्हें फाइंड कैसे करते हैं? बाय दिस पर्टिकुलर compatibility equation. Now let us suppose, guys, if you have two hinge semicircular arch, in case of semicircular arch, let us suppose a point load is present exactly at the crown, then the value of horizontal thrust is W by pi. Please remember this. If the point load is present at an angle of alpha, कोई एक एंगल अल्फा पर प्रेजेंट है बच्चों, जैसे यहां पर आपको दिख रहा होगा, राइट, लेट मी हाइड माई सेल्फ, ये एंगल अल्फा पे है, तो आपका फॉर्मूला क्या हो जाएगा टू फाइंड आउट द हॉरिजॉन्टल थ्रस्ट? इट विल बी W by pi sin स्क्वायर अल्फा. अगर मैं अल्फा पुट करता हूं बच्चों 90 डिग्री, देन W एट द क्राउन, राइट, इफ W क्राउन पे हो गया तो इसका मतलब है H विल बी इक्वल टू W by pi, जो हमने पहले भी देख रखा है, ठीक है। नेक्स्ट वन, लेट अस सपोज इफ UDL is there on two hinge semicircular arch on the entire span, then the horizontal thrust will be 4WR by 3 pi. 4WR by 3 pi. Next, if a UVL is there, UVL, uniformly varying load, on the entire span, so this reaction will become half as compared to the previous case. It will become 2 by 3 WR by pi. And the same case is applicable फॉर हाफ यूडीएल. मान लो यार हाफ यूडीएल है, सेमी सर्कुलर आर्च है और टू हिंज है ना, तो इसके लिए क्या हो जाएगा 2WR by 3 pi, राइट, डन. नाउ लेट नेक्स्ट कंडीशन इज टू हिंज आर्च. सो फॉर टू हिंज आर्च व्हाट शुड बी अवर फॉर्मूला? फॉर टू हिंज आर्च व्हाट विल बी अवर फॉर्मूला? वेट अ मिनट गाइस, ओके. For two hinge arch, what will be our formula? That is basically WL square by 8H. Horizontal thrust is equal to how much? WL square by 8H. Next one, two hinge parabolic arch. For two hinge parabolic arch, the formula for horizontal thrust will be 25 by 128 WL by H. 25 WL by 128 H. That is basically your horizontal thrust. Now guys, if you want to find out the horizontal thrust on two hinge semicircular arch and two hinge parabolic arch, then what should be the horizontal reaction due to the change in temperature? So please remember this formula. It is 4EI alpha delta T divided by pi r square, and this will be 15 EI naught alpha delta T अपॉन 8H स्क्वायर, राइट. तो बच्चों यहां पर आपके पास क्या हो जाएगा? अल्फा क्या है? अल्फा इज नथिंग एज बेसिकली अवर कोफिशिएंट ऑफ थर्मल एक्सपांशन, एंड डेल्टा टी इज नथिंग एज चेंज इन टेम्परेचर. व्हाट इज ई? यंग्स मॉडल्स ऑफ इलास्टिसिटी. आई इज मोमेंट ऑफ इनर्शिया. एच इज अवर राइज, राइट, एंड इन दिस केस आर इज बेसिकली रेडियस. ओके. Now guys, the last thing which I want to explain over here, that is basically the matrix method, which is the last thing. Just you have to remember the property, right, which is nothing as basically our matrix will be a square matrix, and the diagonal element is always positive and it is non-zero. The diagonally opposite element are always equal in magnitude and in sign also. Let me explain it. Let us suppose यार मेरे पास यहाँ पे कोई 2x2 का मैट्रिक्स है ना, तो ये एलिमेंट क्या हो जाएगा? F11, F12, F21 एंड F22. सो ये एक स्क्वायर मैट्रिक्स है जिसका ऑर्डर क्या है बच्चों? 2x2 है. यहां पर जो डायगोनल एलिमेंट है, दीज आर बेसिकली डायगोनल एलिमेंट्स. सो डायगोनल एलिमेंट्स आर ऑलवेज पॉजिटिव एंड इट इज नॉन जीरो इन नेचर, एंड दीज आर डायगोनली अपोजिट एलिमेंट विच इज ऑलवेज सेम. in magnitude and sign. That means F21 and F12 is always same, like this. Okay, done guys. So these are the formula guys, to be true. यार आपके स्ट्रक्चर के अंदर फॉर्मूले ज़्यादा नहीं है, कंसेप्ट ज़्यादा है, बट बच्चा लोग सोचते हैं फॉर्मूले ज़्यादा है. अगर आप सोचते हैं फॉर्मूले ज़्यादा है बच्चों, देन आपने कंसेप्ट पार्ट कहीं मिस करा है ना. मैं आपको बोलूँगा कि फॉर्मूले बहुत कम है बट कंसेप्ट बहुत ज़्यादा है. तो आप कंसेप्ट लगाइए, आपका ऑटोमेटिकली प्रॉब्लम सॉल्व होगा. यूजुअली होता क्या है कि हम स्टैटिक इक्विलिब्रियम इक्वेशन से मैक्सिमम प्रॉब्लम सॉल्व करते हैं, है ना. तो इक्विलिब्रियम इक्वेशन ही हमारे लिए बहुत ज़्यादा यूजफुल है. समझ में आ रहा है. तो बच्चों आपके स्ट्रक्चर के अंदर फॉर्मूले कम होते हैं बट एग्जैक्टली अगर देखा जाए तो आपके कंसेप्ट पार्ट ज़्यादा होता है ना. जितने फॉर्मूले थे जो हम फॉर्मूले के तौर पे याद रख सकते हैं, वो फॉर्मूले मैंने आपको बता दिए बच्चों. ठीक है, आई होप आप सभी को समझ में आए होंगे. तो क्लोज करता हूं बच्चों इसी सेशन को, फिर हम मिलते हैं नेक्स्ट सेशन में और फिर आगे की बात करेंगे जी. ओके, सो थैंक यू सो मच फॉर ज्वाइन द सेशन गाइस एंड कीप लर्निंग. थैंक यू सो मच. देवांशु, स्ट्रक्चर डायनामिक्स आपका मैकेनिक्स का पार्ट है ना, इंजीनियरिंग मैकेनिक्स का पार्ट है, तो वो गेट के लिए इंपॉर्टेंट है, बट वाइब्रेशन वाला, फ्री वाइब्रेशन.